Good day, everyone. Today we'll be answering, is it useful to improve modeling usage of scenario in order to improve the environmental footprint of energy using product? One way to understand the environmental impact of a product, especially the energy using product, is by assessing the life cycle of the product itself. This method is recognized to be one of the most reliable tools for environmental analysis. The energy-using product, as the name implies, is known to have their main environmental impact during the use phase, during which the energy consumption is highest for the whole life cycle. So most of the time, the life cycle assessment is focused on the use phase. To assess the use phase, one will first model every scenario of use possible, and there are tons possible scenario of use. After that, the actual data needed for every model is collected by experiment. This data is then used to calculate the total amount of energy consumed for each scenario. In the end, one will compare the energy consumption of every scenario to find a scenario with the smallest amount of energy consumption, and that specific scenario will be the one with the least environmental impact. Therefore, this specific scenario will be suggested scenario of use for customers. However, this process is not as easy as it sounds. The most difficult part to be done practically is the data collection. Collecting data is a time-consuming activity. Most of the data must be collected routinely for some period of time to make sure that the data is reliable enough for the assessment. Collecting data can also be expensive because it needs several instruments and people to work on in that extension of time during the data collection. That's why most of the times the energy consumption from use phase of a product in the life cycle assessment is calculated from average usage scenario. This average usage scenario doesn't take into account the effect of the usage context on environmental performance, which can be positive or negative. However, this might not be the case of energy using product, because most of the energy consumption in the product's life cycle is in the use phase. That's why we will try to find the answer. Here, in this paper, is it useful to improve modeling of usage scenarios in order to improve the environmental footprint of energy using products? In this paper, the author considered the case of a life cycle assessment of a truck refrigeration unit to determine its environmental footprint. Truck refrigeration unit is an energy-using product in which most of its environmental footprint comes from the energy consumption during its use phase. To begin the analysis, we will firstly take a look into how the author modeled the usage scenario of the truck refrigeration units.
Hi everyone, I'm going to explain about source of data collection for modeling a usage scenario. In order to model a usage scenario, we need to collect some data first. There are 4 types of data that can be used to model it. First, it's real-time data. Real-time data is taken with the help of sensors while the product is being operated. This kind of data is the most reliable but not effective because it takes a long time to collect the data that we need, and the cost that we spend is quite expensive. Moreover, the impact on the environment must be evaluated continuously or only once at the end of the life cycle. The second one is experimental data. When taking experimental data, we need to determine the appropriate parameters for the analysis so that reliable data can be obtained from those parameters. By taking this kind of data, we can analyze the effect of a single parameter or combining several parameters. The third one is numerical simulation data. The numerical simulation data is approached using a mathematical approach. If the product requires other products to be used, it is difficult to control the external parameters. This condition will not only affect the energy consumptions but also can affect the accuracy and reliability obtained by the results. The advantage of this analysis is that it requires resources and materials to be implemented. And the last one, or the fourth one, is average scenario data. The average scenario data is taken from customers, experts, and also reviewers. It is less reliable and the scenario can be far from the truth because less data is required. However, this type of data is very easy to gather and at low cost. And as you can see here, I provide you with a table of conclusion from what I've explained before. This table tells us about the advantages and disadvantages from each method to collect the data to make the model of the usage scenario.
So now I'll be explaining on the data collected. In order to identify which data to collect for building usage scenarios for LCA and sensitivity analysis, the important parameters that can influence the environmental footprint of the use phase must be identified, like the technology, the accessories, including curtains or partition wall, and also the setting from the end user. In this case, it will be the driver, as a setting of the temperature and the operating mode. These parameters can be further characterized using expert or user feedback and or literature sources. A graph is also built in order to model all the parameters that can influence energy consumption of a TRU. This graph is called a directed acyclic graph. This graph is based on literature review and expert knowledge, as there are many internal and external parameters that can influence the energy consumption of the system. This graph helps to show the complexity of energy consumption modeling and the number of parameters that have to be considered to obtain a realistic usage scenario. As a result, only experimental data with specific parameters were chosen, and many of these parameters are actually chosen by the customer or the end user. In this case, it will be the driver. Setting these parameters helps understand the end user's behavior, the personal norms, and his or her awareness and habits. In this study, the author have chosen a few parameters to analyze based on expert knowledge and end user behavior, and the commonly used parameters in scientific literature.
All right, let's continue. So, to support their claims, the authors conducted a study of the different usage scenarios and see how that affected the energy usage of the TRU. So, uh, the authors compared the average scenario, which was obtained from the company Carrier Transicold, which is a European TRU company, and then they compared it with specific scenarios which they obtained from their own experimentation. And in this case, they put emphasis in varying the end user parameters. And we'll see that this does have an impact. Right, so for average usage scenarios, the parameters are set temperature and operating mode. So set temperature is how cold you want your products to be. So if you are transporting fresh products, you don't want it to be frozen. And the optimal temperature is 0 degrees Celsius. Whereas if you are transporting frozen products, put it at negative 20 degrees Celsius, and that is the optimal data obtained from the TRU carrier. And for operating mode is how you want the cooling to work. So for start stop, the cooling only starts when the temperature inside the unit is above the set temperature, and it will stop cooling when it reaches that set temperature, and then it will repeat. But for continuous running, like the name suggests, it will continuously cool the unit, and it doesn't account whether or not the temperature of the unit is above or if it actually is below the set temperature. And this depends on the end user's contract for the transportation of the product. And below we have the tabulation of those parameters. So we have for continuous running, and then 0 degrees Celsius, and it starts off for 0 degrees Celsius, continuous running for negative 20 degrees Celsius, etc., etc. And these were obtained from 150 TRUs. Okay, so for specific scenarios, these are actually obtained from experimentation, and the authors used, I think, 2 TRUs, and they varied several parameters. The first set of parameters are the TRU settings, which are temperature and operating mode, and we have discussed these before. And the second set of parameters are the end user behavior, which is the core of this paper study. And so the end user can change, they can uh, change whether or not they want to keep the refrigeration on or turn it off when opening doors of the TRU of the trailer unit, and whether or not they use curtains for the door openings. And from the experimentation, we will find out that it actually has a significant and notable impact. So these are the results. We end up with 11 specific scenarios. And here, energy is displayed in mean instead of the raw data because it is confidential. And of course, you have the standard deviation from the experimentation. My colleague will then further elaborate the analysis of this.
In order to assess the potential differences between average and specific usage scenarios, the global energy consumption has been calculated based on 1500 hours of use of a TRU. Concerning door openings, we assume one 5-minute period and one 10-minute period during the experimental time of 3 hours. Results shows that depending on the end user or customer's behavior, energy consumption can increase or decrease compared to the average European scenario. This environmental footprint is directly correlated with diesel energy consumption. Energy consumption in specific scenarios ranges from -82 to positive 9.6% of the average European scenario when considering 1500 hours of use of the TRU. Results also shows the influence of different parameters, especially the influence of customer behavior, the use of start or stop operating mode for frozen products, is a recommended setting to ensure a good quality of cold change and less energy consumption. In the European scenario, the use of continuous run for a frozen product hardly happens. It can occur if an end user accidentally set it or the setting is demanded by a customer. Curtains are optional and they are not always used by the end users. The use of the curtains is not included in the European average scenario. Results demonstrate that even when the business of the company strongly influences the scenario of use, the end users cannot affect the energy consumption, for example, by setting the temperature as we can see in comparison of scenarios 6 and 11. When comparing scenarios 6 and 7, in the influence of operating mode, the energy consumption varies by 11.5% for 1,500 hours of use of frozen product. When comparing scenario 8 and 9, in the case of the TRU turns on and off when the doors open, the energy consumption varies by 6.2%. The influence of the use of curtains when doors open in scenario 9 and 10 involves a change of energy consumption of approximately 27.5%. As a result, the environmental footprint of the use phase can be significantly influenced by the end user's behavior. Results can also show the importance of taking into considerations the business activity of the customers. The business activity mainly concerned the type of transported products and the type of delivery. The business activity will also influence other parameters linked with the end user behaviors. So, the global energy consumption for the whole lifespan of the product and the specific recommendation to the end users will not be the same. This paper shows that the specific usage of an energy-using product can alter the energy consumption in a considerable value. Hence, it is proven that using an average scenario is not recommended in a certain value for energy-using product. However, as mentioned earlier, the experiment also faced common problems and difficulties. The studies of experimental data took almost 2 months to be performed due to the size of the system, that is the trailer refrigeration box. This experiment must be conducted over a long period of time in order to ensure the thermal stability of the system for a better accuracy of the data. Finally, the study showed that it is possible to maximize the beneficial specific usage recommendation for customers. One of the examples that is mentioned in the paper is by using an eco-feedback strategy. So the strategy is done first by experiment to collect enough data for initial specific usage recommendation. The initial experiment is not including all parameters, but only the critical one. After that, the user activity will continue the job, that is to collect data and evaluation during the operation period. This information can be used to adjust the previous specific usage recommendation so that the highest saving of energy consumption could be achieved. This strategy will reduce both time and cost of the assessment while still giving the best saving possible. Finally, the result of the paper have proven the importance of giving specific usage recommendation to the customer to improve the environmental footprint of the energy using product. Therefore, it is also important to improve the modeling of usage scenarios in order to get the best result of specific usage recommendation without compromising the practical factor such as time, capabilities, and equipment availability. If you enjoyed this video, please give us a thumbs up or leave a comment below. See you next time!